Welcome back, everybody. This is lecture 3, all about asynchronous networking in JavaScript. Let me share my screen and we'll get things going. Okay. Today is all about XML HTTP request and networking with it. Just an overview about our roadmap here. So we first talked about the client-server model, and then we moved on to talking about concurrency and JavaScript. We talked about the event loop last time. But now we're finally going to move on into figuring out just how to make this a reality. So we know the event loop allows us to perform asynchronous execution, input, network, all this kind of stuff. But we don't know of an API that lets us do the networking part. And XML HTTP request, of course, is what we're focusing on today. So here we have a minimal example, and we'll be seeing more code like this. So don't be too alarmed if you don't quite understand it. But things to know: XML HTTP request is a built-in API in browsers, much like document and fetch, as we'll see. But this XML HTTP request object and me storing it into this XHR variable, this is a handle that represents an asynchronous request. By default, it's asynchronous. You can change it, but I don't know why you would. We talked about some of the problems last time about why asynchronous execution is potentially a very big problem in the web browser. XML HTTP request actually has quite a few docs. Can I click that? I think I have to actually go out of the laser pointer. So this docs link just takes you to the MDN list. If you guys haven't got into the habit of reading docs or things you don't know, I highly recommend it. Everything I'm going to tell you today is written down inside of this docs, but you can see, for instance, all of the different events that you can hook into, and you can see different things that you can do with methods, like you can stop a request once it's already been set, which is pretty cool. You can add extra headers through set request header, which we probably won't be doing here, but it exists, right? So if you guys want to get a complete discussion about XML HTTP requests, then I recommend reading these docs. They're pretty good. They're honestly pretty good, but that will not detract from what we're going to be talking about here. So the basic flow of this is you create a new XML HTTP request object. Initially, it's empty. It's empty. So we're going to fill in the details, and that's what this open does. Open initializes the request with the HTTP method, also known as the HTTP verb. So this is just going to be a get, and then we pass it the URL that we want to get in this case. Naturally, I'm just linking to the docs because I couldn't think of a better URL to link to. I think that's pretty cool. Now, let's talk about sending to actually start the request. The way we send the request is we call XHR send. And the canonical way of doing this is that you wrap it inside of a try catch like this. And the reason is because sometimes the request will fail to even send. And the way XHR resolves to telling you about this is by throwing an exception. That's why you should wrap this in a try catch and then do better error handling than just printing out what the error was. You probably want to retry at some point. But you wrap it in a try catch like this, and you customize what happens with XHR through these callbacks. Onload is the primary one for when the request succeeds. Yeah. So you literally assign to this property, this XHR.onload property, you assign to it a function, and that function has access to XHR via this captcha. And you can check things like the status return code. You can check things like the status return text, which will be okay if it's 200. And then you can also grab things like the response with the response body, things like this. We'll see more of what's inside when we get to the code example. But you can already see that we do, like, what would you say, sort of unexpected error handling, we do via try catch. And HTTP style error handling, like for instance, you accidentally misuse an API, or you, like the user, say you're trying to log into a form, like users entered their password and username into a form, and they've accidentally misspelled the username, and you're sending off this information to a backend server to do authentication. If the backend server has been programmed correctly, it should send back a 401 maybe, something in the 400 range, to represent like user sent invalid arguments or something like this. And you would check errors like this with the XHR status. That's almost an expected error, because you expect people to make mistakes every now and then. And so you check these through the statuses, right? Yep. And the other important thing to remember or sort of know about is that XML HTTP requests have, they've fallen out of favor. It's kind of old. And you can tell it's old because it's still talking about XML when we know that JSON is dominant nowadays. And so you might ask yourself, why do you need to know about this if not many people use it anymore? And the reason that you might want to know about it is because legacy code bases exist, and they will exist forevermore. And so it's good to know all of this stuff. Cool. So we're just going to go straight into a demo with this and just take a look-see at exactly how this works. I think that's gone straight back to the start. This one. Okay. So if I go back to WebStorm here and we look at this, here's our index.html and our JavaScript, which I will increase. So this basic application, if we just load it up, it's going to use an API called IPify. I think that's how you say that, IPify. It's an endpoint that will tell you your IP address of the network that you're currently on. So right now we haven't run it, so we don't know what it is. If we click this button, then hopefully this will update with our IP address. And so since we're going to be fetching from a remote resource asynchronously, we're going to be doing this with XHR. So let's write the code that does that. We have a function main, so when we click, we will call this fetch IP. So let's do it. The first thing that we need to do is initialize our request. Well, we need to create an empty request handle first. So let's go ahead and do that. XHR will be a new XML HTTP request. This, and then we need to initialize this request with the details of what we're doing. So the way we do this is we say get. As you can see, I have IntelliSense on, so it's giving me interesting, what would you call this? Interesting autocompletes. We won't be using the second way, we'll just be using the first one. So we have get, and then it takes the URL that we care about. And let's fill in the skeleton first by this try catch. So we'll do xhr.send. And if we catch, we'll do nothing. Well, we'll console.error. Could not get IP address. Maybe retry? Maybe. I don't know. We probably won't retry. I do know. I lied to you. So remember, we customize the features of XHR via setting properties to callbacks that we create. So let's go ahead and do that. The one that we care about, and the main one that we'll care about always will be, well, here's a bunch of them, right? On timeout. So you can set timeouts as well, which is interesting. Like if a network request takes more than a second, you can stop it. On progress, if you want to have like a progress bar, load start, load end, kind of superseded mainly by on load. But if you wanted to have something that happens like right when you start the request and end the request, and then right when you start the request, you can do things when you abort, on error, all of these things. We're going to do on load because that's the primary one that people use. So we'll set it to be this. We will first check to see if the status code was 200, 200 being the HTTP code, meaning that everything was okay. And if it was okay, then what we're going to do is get the response. So let's just go see what this actually returns first. If we go to this address in our web browser. Okay, cool. So it looks like it's sending back a JSON object with one key called IP, and that's my IP address, my IPv4 address. Please don't hack me. So we'll have our IP be equal to XHR dot response. So there's a bunch of things. There's a response text, which returns whatever the response is as a string. You can see what the actual response type was. You can get it from the URL from where it responds. You can get it as an XML thing if you wanted to. No to JSON, unfortunately, because it's an old API. So we're just going to go with response text to start off with, because it should return it in JSON. The API here should return it in JSON. And then what we're going to do is we are going to grab this EM, this italicized unknown, and we're going to change it to what our IP address is. And the ID is IP text. So we'll do document.getElementById, IP-text, and changing the text content to IP.IP. Right, because if we look, I think I closed the tab, didn't I? If we look at this, the key is IP, so we have to grab it like that. And that should be everything. I suppose if the status isn't 200, then what we'll do is we'll just console.error, right? We'll not get the IP. Rest in peace. Cool. Put that there, forgot that. I'm sure somebody was screaming at me then, put in the E. But yeah. And then just for lols, I suppose what we'll do is we'll also add a text inject, which says in the success case, this can be like an H3. Super scary. Okay, let's go ahead back to our web page and run this. So give it a reload and we'll see. Fetch the IP address. Huh. That didn't work. Why? Well, I know why this didn't work because of that. But why didn't this work? They know where I am, but I don't know where I am. So what's happening here? Of course, it would be so much if you guys were the tentative not tentative, what would you say? Keen-eyed amongst you would have noticed that I said that this was a string, right? But I'm accessing the string as if it is a JSON object, which isn't the case. This will be a string that looks like JSON though. So if we actually want to grab it as a JSON object or a regular JavaScript object, then we have this nice built-in module in the browser called JSON, and it has this parse function. So we can go ahead and construct an object from our JSON stringified representation. And now this should be fine. Yay, there it is. And the government knows where I am. Oh no, scary. Cool. So it's fairly simple, right? It's fairly simple. We just customize the onload function to actually do the thing when we get our response back. But we'll talk more about style things with this in a second. Let's go back to the presentation. I think that's a good spot. Yeah, a little bit up. So I wanted to say a few more words about how to handle problems, so things that happen. And I kind of hinted at it before, but we have two classes of errors, right? The first one are these expected errors. And these are the things that you kind of, again, expect, right? Authentication problems, bad parameter problems, non-existent domain problems. You'll get like a 500 for something like this, I think, maybe. in any case, your expected errors generally are communicated to your application through the HTTP status code. So you'll get a 400, 401, 403, 404 classic codes for like not using an API correctly. And this when you get a 4XX, generally what this means is that your user is misusing an API. 500 or 5XX, 500, 501, 503, 502s are a bit more difficult to deal with. Therefore, the server-side problems, the best strategy for that is kind of to retry or just to report an error. And of course, 200 means that nothing, no problem occurred. So 200 is good. We want 200s. The unexpected side, however, these are generally our exceptions, right? And we handle these via try catches and one more way that I'll show you in a second. But like unexpected errors, network connectivity, you're on a train, back when riding trains was a good idea. And then like you're going through a tunnel, right? Or like the classic movie scene when somebody's going through a tunnel and their cell phone loses reception. Network connectivity issues, they just happen. Remote connections drop. Remote connection drops, again, just happens. Timeouts, generally you don't expect timeouts to happen because in a perfect world, everything's very fast, but it's always a good idea to have timeouts. This would be related to like internal servers, servers internally failing, or if you're being redirected a trillion times because you've accidentally clicked on like a really dodgy link, then, or you're using a super dodgy API, then you want timeouts as well. Yeah, like I said, these are handled by try catch blocks, right? They're just exceptions. And the best strategy is to retry with the caveat that you use an exponential backoff algorithm. What this means is essentially is that you might retry once every 10 milliseconds, but if you like after you retry 5 times, probably 10 milliseconds isn't enough time. So you would start at like 10 milliseconds, maybe go up to like 100 milliseconds, maybe like 300 then, and then 500 you would wait, and then maybe wait 1 more second, and then maybe wait 2 seconds, and then you stop. So it's it's a back off like that. And then at some point you just have to like fail until the user that they can, whatever that they've tried to do can't be done. And so you report an error, show a nice like graphic animation, give an alert, things like this. Let's see this in action. Okay, close this, come down here. Okay, increase the font size again. So this will be an example we'll be using in the next 2 lectures as well. So let's get familiar with it, shall we? Let's load it up. Basically, we are going to get our daily vitamin Chuck Norris, and we will get our, what would you say, daily dose via praise of Chuck Norris. Of course, nothing happens right now because we haven't written the code, but essentially this is what we're going to be working with. So if we come to our index.javascript, we are going to do essentially the same thing that we did before. So let's go ahead and create const XHR, new XMLHttpRequest. And then what we're going to do is we're going to initialize it with open. These are going to be gets, and then pass in my URL. Try catch again, because we should. All of this is fairly boilerplate at this point. If we catch an error, what we'll do is we'll just log it again. In general, naturally, you don't just want to log your errors. That would be a bad thing to do. Cannot stand, shall we say. So we'll customize again via onload. And actually, these onloads, if you just look at this prototype, it can actually take a, I don't know if you guys can hear that, somebody's dying outside. This can also take a progress event thing. This is for like progress bars and stuff. So you can use this for spinners or progress bars. I won't be using that here. Okay, so if we get a 200 again, then we'll just do some means, which will be document.getElementById. This one is mean text content. Well, I guess we'll have to parse it, won't we? So const mean equals JSON.parse XHR.response. So response and response text are the same thing if the response actually is JSON, because XMLHttpRequest doesn't by default support JSON. And I don't actually know if you change the content type, it will come back as JSON. That's mainly if you're sending like things in the parameter of the request. I think when you're getting the response back, it's up to the server to decide what it is, but well, that's more of an aside than anything. This will work. So we'll do meme, and I know what the value of this. Hang on about this. It went away. Don't you hate when that happens? I know that the meme will be inside of the key called value. So if we just quickly run this again, we should see it work without a hitch. Yay. Chuck Norris once went to SeaWorld and wrestled an orca to the death. Very scary. Very meme-like, I suppose. Let's see all the things that can go wrong. The easy one is that, did you guys know that you can like turn off your network in Chrome? If you go to the dev console and you go to the network tab, you can see right now I have no throttling. But let's say I throttle myself and go offline. If I then try to praise Chuck Norris, well, nothing happens. Surprise, surprise. But you'll see I got a network error, network disconnected 200. What's interesting here is that it didn't actually change. It didn't print this error. And that's because for that kind of network disconnected problem, that might be for Chrome specifically, but in addition to onload, there is also an on error. What would you call this? Like the handler, I suppose, that you can set, which again takes a callback. And what on error is for is in along the way of sending. And so I suppose what's happening with Chrome in this, yes, no internet now. What's happening with Chrome is that it's simulating error disconnected error. If you look at the, well, the console won't show it now because I'm offline. No throttling, reload. And then this might break again because I haven't, like I'm in the middle of writing the code, but we'll see what happens. Turn throttling back on, offline. And then praise Chuck Norris. Okay, no, so we did get through. You can see that the error that Chrome is sending back is an error disconnected. And what this is more along the lines of like, whilst it was sending, it caused an error. So it's like slightly different to this. This is like if you can't even, like for whatever reason, like you just straight up can't send. But for when it's an error disconnected, it seems that this one is the one. You'll have to set a callback here, and you'll see what I mean. If I just do console.error here, it will be could not, let's say cannot start sending requests down here to make it more informative. And down here, we'll do could not complete sending request. If I go back to here and turn off throttling, reload, turn on throttling, praise Chuck Norris, and then look at the console. Now you can see that we printed the error message. So it happened along the way. So when things happen along the way, you need to set this error handler. I can't simulate this, unfortunately, but you should still do this for good practice if you're using XML/HTTP error, because this can fail. Actually, I can, never mind. If I copy this, I just remembered how to do this. So one thing that you should know is that if you try and send a request that's been sent already like this, then if you try and call this again, it will throw an exception. So that's a good way to show. So if I just turn throttling off again, reload. If I look at my console now, you can see that we sent it once, and then when we try to send it again, that we got a console error. So not always would you write code so stupid. So you should always just wrap this for good measure. So we can get rid of that. The other problem is, so we've looked at when things go wrong along the way, when things go wrong at the start of the way, and now we'll be looking at an error for when things go wrong at the end of the way, i.e. we don't have a 200. So again, we'll just console the error. And this time what will error is the status text and the status. If you guys don't know what I'm using right now, this interesting like dollar brace things, this is what's known in JavaScript as I guess template literal. It's just string interpolation. It's like a format string in Python, if you guys remember what that is. And if you don't remember what it is, then you can just look up the backtick version of strings in JavaScript. So the way we're going to get this to happen is if I just use an invalid request. So blob, this URL doesn't exist. So if we go back to here and we try and praise Chuck Norris, oh no, we got a 404, but there was no status text, which is why nothing printed. But we can see we got a 404 here. And that's because this resource does not exist on this server. Yeah, so you can see we didn't get a 200. We jump down here. And we're going to say error since status text doesn't exist or it wasn't filled. Yeah, there we go, error 404. So those are the three primary strategies, error handling strategies for this. Let's go back to the presentation. Yay. Okay. So there is a tendency sometimes to, when you have like data requests that kind of depend on the previous request succeeding. So in this example, we might have like get all the users and then get all the posts for a specific user, then get all the comments for that post. We get this like nesting effect that goes on. And this is called callback hell. Somewhat of a meme term, but also is a very real thing. And this generally happens when you have many different people working on the same piece of code and they just need something to happen like right there and then. And is the result of not really thinking not doing any forethought about how the code should be structured, right? And I don't know, this is somewhat if you just go searching on the internet, I think on GitHub, the most used language is JavaScript. So by far, the most sort of software that is written is web front end stuff. And that means it attracts a lot of people of different technical backgrounds, right? So to them, they may not understand things like SRP, which is the single responsibility principle, or they may never have even heard of it. Maybe they don't know what dry is, don't repeat yourself, right? And so the idea of avoiding callback hell is that we should definitely apply these software engineering principles, right? Functions should only do a single thing. These callbacks do a single thing, but their usage context is their usage context is wrong, right? We should split out these things into separate functions. It's much easier to read like this, right? Much easier to maintain, much easier to avoid the hell that is the callback hell, right? And if you're worried about like your bundle size getting big because function is what's that, like 8 letters, and that's like 8 more bytes you have to send over the internet, then you should let your bundlers minimize your code for you and not you doing it. We don't want to sacrifice expressibility like this for trying to save a few bytes, right? So my tips for you guys is that where you can, avoid flat over nested. I know in the example, I just use a nested callback, but that's because it was it didn't nest like this, right? But this is much more like, what would you call, dependent operations. Yeah, use these lambdas, these arrow function things for easy one-liners, things that don't nest or don't recurse. But when you're doing non-trivial logic inside of the callbacks, make them functions. Do the right thing. Named functions, I should say. So we finally have a method of making an AJAX web app. We finally progressed to like 2002. Excellent. But I mean, if you look at the API for XML HTTP requests, it's kind of tedious, probably error prone. Can we do better? I think we can. And so that will be the topic of next lecture, where we'll be talking about promises and networking with the Fetch API. So my promise to you is that I'll see you next time, guys.